started. Our next speaker is Dr. Courtney Brown. And I've known him for a long time. Over 10 years, I trained with him at the Farsight Institute. I think Dr. Courtney Brown's version of a perfect world would be like this. In Dr. Brown's perfect world, KITV and ABC would pay me to report about remote viewing and consciousness. And in a perfect world, according to Dr. Brown, Emory University would pay him to teach remote viewing and study consciousness in remote viewing. Emory University has just allowed him to refer to remote viewing off campus and use the term Emory University. That's good in a way, but kind of sad in a way. Courtney Brown made a huge splash in the remote viewing world and the world at large a little over 10 years ago when his first book came out. And then after that, he kind of disappeared and started doing some research. And we'd email him, and how you doing, Courtney? And Glenn would call him, and what are you doing? He'd say, I'm doing some research. I'm kind of staying out of the light for a while. So we call him, hey, come on, we want to know what you're doing. I was doing a remote viewing newsletter, and I'd call him up and email him. Courtney, I want to interview you. No, not ready to talk yet. I'm doing some really serious work. Well, he's finished that work, and he has a new book out. This is going to be the topic of some of his discussion today. So finally, Dr. Courtney Brown is ready to talk. I'm so happy he's here today, and we're ready to listen. So, Dr. Courtney Brown, the stage is yours, sir.
Well, I'm pleased to be here as well. Let me clarify a little bit, so I don't get in trouble, about who I am, what I do. I'm a professor in a social science department. I'm a mathematician who happens to have a job in a social science department at Emory University. I do not do any remote viewing work or research at Emory University. I do that all outside of my work at Emory University, and I do that under the auspices of the Farsight Institute, which is separate. It's a nonprofit. And I have never received any financial compensation ever as director of the Farsight Institute. So, just putting those little preliminaries aside. Dick mentioned some interesting things about my early work. My work can be divided into two periods, early and late. The early stopped around mid-90s, and at that point I was interested in applying remote viewing to the study of extraterrestrial life for a good reason. I didn't know much about remote viewing. I was just learning it. And I had to pick a subject, and it was an interesting subject, the subject of extraterrestrial life. So I did a lot of sessions about extraterrestrial life and wrote 2 books about it. And they were not scientific works by any means, because you could not get verification for any of those targets that I did until much later. So I'm still waiting, and I will wait a long time, as long as I'm alive, to see how much I got right and how much I got wrong. And it's an interesting stuff. Unless I published those books, we would never have the answers to those things. So it's good to do sessions and put it out there so you can sit around and wait just to see what actually happens. So I'm very optimistic about those books, but I don't know. They're not scientific, but they're really interesting, and I like to have done those 10 years back. Well, for about the last 10 years, however, I haven't done anything on extraterrestrial life, and some people come up to me still to this day and say, what do you think about? I have no idea what they are thinking about. I haven't read the National Enquirer for at least a week, and I don't know anything about that other than what I published about 10 years ago. So what's really interesting to me now is not the application of remote viewing to anything, be it missing persons or extraterrestrial life or anything else. What's interesting to me now is the science of remote viewing, the phenomenon itself. It is so interesting, and I hope to infuse you with the sense of excitement that I have about that. It is so interesting because it is planet-shaking in its potential to change people's way of thinking. So the extraterrestrial question is an interesting one. It's sort of fun. I did it while I was learning, and that was a great thing, and I'm so glad those things are out there. But believe me, the science is even better. It's even more exciting. And let's talk about that. So, there are two websites that you're going to want to know about. You probably already know about them, but this is being recorded for posterity. So for people who are watching the recording, let me mention it's www.farsight.org. That's spelled like seeing far, and org because it's a nonprofit. And there's tons of information free about the remote viewing phenomenon. It's a huge library. And there's also my own personal website, CourtneyBrown.com, where you can find out about me should you be interested. I do other things, and most of the time I'm talking about mathematics, mostly nonlinear differential and difference equation systems. That's my specialty. That's my niche. I have a couple new books out on that just came out this summer. So that's a really interesting subject as well. It is very, very interesting that the use of math has allowed me to enter into the realm of quantum mechanics because it's a similar language. So what we're going to be talking about today is some of the new science about the process of remote viewing, not the proof of remote viewing, but the process of remote viewing, and some of the great wars that are going on there. And I'm not talking about Iraq or Afghanistan. I'm talking about the intellectual wars that academia is fighting that are really, really exciting. And then we're going to be talking about some quantum mechanics. And believe me, I won't lose anyone, but the quantum mechanics stuff will turn your head on your heels when you realize that that's what you're dealing with. So let's move on. Psi war number 1. That's the one everyone was asking Dr. Utz about earlier today. Does psi exist? Does remote viewing exist? Is it a real phenomenon? Dr. Utz already gave you the answer. Yes, it's a real phenomenon. There are a lot of people that are not willing to look at the evidence, but that's not the reason to continue fighting that war. That war, does psi exist? It's a stalemate. You can't win it. There's a lot of people shouting at each other. There's a lot of people yelling and screaming and arguing and pointing and saying, you cheated, and all types of stuff like that, and said, I dare you. It's going to go on, and it's going to go on, and it's going to go on. Don't even bother. It's one of those things when someone enters that type of debate, you just say, never mind, let's move on. Sometime, someplace in the future, somebody will get a Nobel Prize in physics for their work in consciousness, and that'll end the debate, just like the debate was ended with regard to whether prions cause mad cow disease. The person who made the first article on prions causing mad cow disease, after he published it 15 years, nobody called. Nobody wanted him at a convention. Nobody wanted to talk to him. Suddenly a Nobel Prize dropped in his lap, and he's Mr. Hero, and the Academy was saying, and he's one of us, he's one of us. We knew him when. Well, let's talk about science. You know what's so really interesting about science? It's just like the bully at the beach. The bully at the beach. And the bully at the beach comes up to you and says, I draw a line in the sand right there. Don't step over it, or your face is mud. Well, you realize, hey, what's he going to do? So you step over it. You call his bluff. And he says, whoa, you blankety blank. I'm drawing a new line right here. You step over that line, and your butt is you-know-what. And the guy says, let's see what he does. He steps over the line. And then the bully backs up again and says, okay, this is my last thing. This is my last. I draw a new line. If you step over that line, that's the end of you. Well, eventually, you know what the guy's going to do. He's just going to keep on backing up and backing up. And then eventually, he'll tell you, extraordinary claims require extraordinary evidence. He'll tell you, my line is very far away and you could never get to it. You know what that's called? That's called the alpha level of the test. You see, scientists always work with two hypotheses. How many people have seen Fiddler on the Roof? Most of you have, right? Tradition! Tradition. Tradition. It's the way we've always done things. Tradition. Tradition is the null hypothesis. It's the way things were before you came around with your fancy-dancy idea. Tradition is the way we are now. And if you want us to break from our tradition, then you've got to show us a lot of proof. What does science normally ask? Well, Dr. Utz told you today, They normally build a 95% confidence interval around their test statistic, around which there is a 5% chance they could be wrong. And they want you to show them that if they accept your different hypothesis, so that they have to give up their tradition, which is the null hypothesis, there's only a 5% chance that they could be wrong. So if you reduce the odds down to that little, only 5 out of 100, then they're willing to say, okay, we'll get rid of tradition, we'll get rid of the null hypothesis, and we'll accept your alternative hypothesis. Now, there's a big debate about whether thimerosal, which is a mercury-based preservative that was used in vaccines up until 2002, causes autism. And believe me, people are very upset about it. CDC does a major study on that. And they conclude the 95% level, they are absolutely certain, only 5% chance of being wrong, that mercury does not cause autism. Now, that was good enough for legal cases. All types of suits are involved, and CDC is getting involved, 5% chance. Okay? So the 95% confidence and a 5% chance of being wrong is the normal that's accepted. Now, the null hypothesis is always that there's no relationship. Nothing is going on. Psi does not exist. Remote viewing does not exist. The other hypothesis they call the alternative hypothesis, or the alternate hypothesis. And the alternate hypothesis is your new fancy-dancy idea that psi does exist, that remote viewing does exist. And so what's been happening over the years is the big bully on the beach has been saying, there's my line in the sand. You don't cross it. Talking about the 5% level. You pass that. Dr. Atz already talked to you about that. They long ago passed that, a long time ago. Back up. Okay, here's my new line in the sand. No longer the 5% chance of error. No, now make it 2% chance. Oh, you pass that. Whoa, the new line in the sand. 1% chance. And then it gets to be 1 out of a million chance. And eventually the guy says, extraordinary claims require extraordinary evidence, which is basically saying, I'm moving my alpha level to whatever I want. I ain't going to listen to what you have to say. That's not science. That's not embracing or defending science. That's the complete abandonment of science. So what you have to understand is psi war number 1 is just not worth fighting because they've broken the rules. But listen to this. That is called a type 1 error. If the null hypothesis, which is H0, is true, but you reject it. Ooh, you don't want to do that. You don't want to reject something that's true. You're already stuck with tradition. You don't want to get rid of tradition if, in fact, it's true. So you want only a 5% chance that you could be wrong. That's good. All right. So you don't want to do a type 1 error. That's what Carl Sagan's worried about up there. However, if H0, the null hypothesis, tradition, is wrong, and you don't reject it, if remote viewing and psi really do exist, and you don't reject tradition, then you've made a type 2 error. Now listen, folks. If you make it impossible to make a type 1 error by removing your alpha level to way up into the mountains and beyond, if you can't reject the null hypothesis, then what's the chance of making a type 2 error? It's humongous. They've made a type 2 error. There is no way around it. Now, this is the interesting thing. How can you get your cake and eat it too? Well, you can get your cake and eat it too by reducing the chance of a type 1 error and a type 2 error if you increase the sample size. The more times you do something, the more robust your statistics are, the more accurate they are. Technically, the smaller the confidence, the smaller chance, the more narrow the confidence interval. So really what you're talking about is less of a chance of making a mistake. So that has led to a problem in the scientific community that does study psi, and that's very interesting, because that's where I come in. There's another psi war, and those psi war. That psi war has to do not with whether psi exists, but how to study psi. And there are scientists, lots of them, very good ones, that have all types of different opinions about how to do it, and that's the big war that's really interesting to fight. They're fighting over experimental designs, all types of measurement issues, and analysis issues. How do you actually do things? Very interesting. And we're going to cover some of those right now. You're going to see how complicated this actually is. And it's way more interesting than Psi War number 1. Well, blazing hot that war is, we found out, well, we meaning those of us who sort of agree with some of the stuff that I've been talking about, that there are a lot of very serious flaws in some early psi experiments. And that there's a misunderstanding of how psi actually works, the actual process of it. A lot of the data that are in a lot of the journals, in my opinion, are seriously compromised, fundamentally flawed, not optimal, but really corrupted. And new designs fix those problems. And we're going to talk about what those problems are. Now, I'm not saying you must believe me. I'm just saying this is my point of view, and I know I got it right, but so what? It's going to be maybe a year, 10 years, 20 years, 100 years before finally someone says, hey, I think Courtney did get it right. It doesn't matter. I did it just because science is fun. Well, there's a book, Remote Viewing, The Science and Theory of Non-Physical Perception. That's the result of 10 years' work. It's already sold out in the book room right over here. However, it is available at Amazon online. I don't get any royalties from it. Everything goes to the Institute to support research, such as buying paper for the printers and new computers and stuff like that, the phone lines. So, Remote Viewing, the Science and Theory of Non-Physical Perception. You can get to it by going to either our website, CourtneyBrown.com, or farsight.org, or going direct to Amazon.com. But here's the book. Now, this was an actual RV target. Let's talk about some of the results. An actual RV target, meaning somebody was given that. I and other people have been given that, under blind conditions, of course. Now, this is a computer approximation done in Photoshop of what a really sort of typical good picture would look like in the mind. Now, you're trying to figure out what that is. Now, a lot of people, when they're brand new, would say, oh, I know what the target is. It's Darth Vader. This is a set in Lucas's Star Wars drama. That's Darth Vader. I know it's Darth Vader. It's right there. There's this Luke Skywalker coming in on the little... And it goes on and on and on. You see how hard this is to decode? You have to actually probe around and say, oh, it's sort of man-made, but... Yeah. Well, you all know how to do that. I don't like to speak to the converted on process-oriented stuff, but that's approximately what the low-resolution image looks like. Here is one of my sessions, and I'll show you some sessions from some other people. And I show this to people who have never done remote viewing, so I'm not going to dwell on this, because you already know what that type of stuff is about. This is interesting. There are different ways to task remote viewers. Well, scenario number 1 is very typical. Scenario number 1 is when you have a target in the past. We've already mentioned the Battle of Gettysburg. And the tasking time is, well, say that's now. And you say, okay, I'm going to target that thing. I'm going to be the targeteer or the tasker for the Battle of Gettysburg, and I'm going to give it to so-and-so. And the person will do it maybe next week or tomorrow. And so you send an email, hopefully no personal contact. You don't want them even to see your face. That's how we do it at the Institute. You don't want them to even see you. An email is best saying, there's a target, go ahead, do it. And then the viewing time is in the future. So the thing happened in the past, then the tasker makes the choice of what the target's going to be, and then the viewer does it. That's traditional. That's the way it's normally done in the remote viewing community. The other time is when the tasking time is first, but the target and the viewing time is in the future. Meaning, sometimes, I have heard, I wasn't in the military, but some people have told me that sometimes remote viewers were used to task something that was going on in real time, such as during the Iran crisis where there were hostages in Iran. They were being asked to find out about those people right now. So the tasking time, the time when they were actually decided that they were going to do that, was in the past, but the target and the viewing time, meaning they were supposed to be looking at something that was occurring right then, is in the future. This is what we do at the Institute the most, scenario number 3. It's really cool, it works really well, and I strongly encourage you to try it if you haven't done it so far. The target time is in the past, meaning the Battle of Gettysburg in the past, or the Eiffel Tower when it was first constructed, or whatever you want to do. The viewing time comes next. The target hasn't been chosen yet. You do the viewing first, and then you let somebody know you're open for a target whenever they can get around to it, and a week or two later, they send you a target. Now, we've done that on a 6-month public demonstration. That is our preferred way of doing it. This is not precognition where you're trying to read something a second before or a split second before. You're trying to predict or actually view a target that's not been chosen for a week or two. And we did that for 6 months in a public demonstration. Tens of thousands of people were participating. What happens is you take your session, you encrypt it using PGP, which is free software, I believe uncrackable, and then you let people download the session all over the world. And then you wait for the tasker, and the tasker has to be some very believable person, some with a higher degree of reputation. We had John David Berryman, who's a medical professor at George Washington University, and he was head of the ethics committee. He also had a law degree. He had a really good background. So for that 6-month demonstration, we had him pick our targets, and we would simply wait for him to give the target. A week or two later, he would give them, and then we would post the target plus the password that would de-encrypt the session that tens of thousands of people downloaded, and they would look at it. It works with any type of procedure. It works with HRVG, it works with SRV, it works with CRV, it works with anything. It's really fun to do. It gave us the heebie-jeebies to start with, I agree. But once you get used to it, it's so nice to know that you're doing a session and there's no way to corrupt it. Because the session hasn't been done, the target hasn't been even chosen yet. Okay, now let's go on to some of the problems that are so interesting to look at. During an experiment dealing with, Marty, listen, the lottery, making money. We were trying to do a thing where we were trying to do sessions, and the sessions were being the targets were being determined by a dynamic event. In our case, was a lottery outcome. And the lottery outcome was being put into binary form, so we had ones and zeros, and then that was choosing a target. And so we had two viewers. Actually, we had two pools of viewers. These are two viewers. Viewer number 1 was supposed to view the comet Shoemaker-Levy. And viewer number 2 was supposed to view Lewis and Clark's first meeting with the Indians at Council Bluff. Now, one of those targets was associated with a 1, and one was associated with a 0. And the lottery outcome determined which one was correct. One was supposed to be viewing the correct target, and one was supposed to be viewing the incorrect target. This is what they handed in. Now, these targets, we had no bounds on them. They were totally random. Nothing, there was no slippage, there was no error. Nobody knew, those people had no idea what the targets were. And that's what they came in. Both of them had very good pictures of a comet crashing in to Jupiter. What happened to Council Bluff? What happened to the Indians? This isn't a thing where they were, there was a decoding type of a problem. They both got the same target, but one of them was the wrong target. That's weird. It's called a displaced target, or sometimes people call it the cross-cutting side channels problem. Here's another situation where there were two targets, same type of thing. The alternate target, it was the target that was not supposed to be viewed, was the Golden Gate Bridge, and the target that both viewers were supposed to get was the moon Callisto. After the dynamic event came in, this is what they got. They both got a bridge. I mean, there's no way to fiddle with that interpretation. That is not the moon Callisto. So they had a displaced target. Both of them had a displaced target. I mean, this wasn't the Mona Lisa. This wasn't the Eiffel Tower. This was clearly one of the two targets. It was the wrong one, a displaced target. Well, I'm a mathematical modeler. I'm not going to get you too deep into this. I just want to show you how I think of things. I don't think of things statistically. I teach statistics at Emory, but I don't think of things statistically. I think of things mathematically. It's just the way my mind works. I think of things in terms of a model, like a sculptor would shape things. I shape things with equations. I worry about the estimation stuff afterwards. What I do first is shape things. And so what I said, well, really what we have is a problem that can be broken into two perspectives. I'm going to give you an anecdote now. This is not the proof. This is an anecdote of something that occurred that led us to understand what was going on. And then we did tons of tests to confirm it. There was a session, a lottery session again, in which there were two targets. One target was Mount Everest. The other target was TWA after it had crashed at the bottom of the sea. TWA Flight 800 after it had crashed at the bottom of the sea. And I did the session, and I had a perfect Mount Everest session under totally blind conditions. And then there was another viewer who I thought was almost as good as me. Listen very closely to what I'm saying. Hey, I'm really good. I know it's going to be Mount Everest. I can't wait to see what the lottery outcome actually is. I know I got it right. And this guy's almost as good as me. Wow, it's going to be cool. He's going to do it, I bet. Sure enough, I opened up his pictures. I opened up his session. Perfect Mount Everest session. Pretty good. Then I said to then I got the second session. I was doing the judging, mind you. And then I got the second session, which isn't good, but I'm just telling you what happened in some of the early days. Then I brought in the third session, actually, and it was a woman's session. And I said, she's good, but she's not as good as me, and she's not as good as him either. She's not going to be able to do what I did, but I bet she'll get some of it. So I opened up her session, and the first 7 pages were perfect Mount Everest. And after 7 pages, I was probably going to start feeling a little humiliated, and I said, this can't continue. She's not as good as me. I turned the page, and the whole session changed. It was a perfect TWA at the bottom of the ocean session. She smacked right down there. Suddenly she said, I don't know what happened. She wrote, she's at the bottom of the ocean. There's a crumpled metallic thing at the bottom. There's divers actually down there trying to look at things. She drew everything. And it went on for another 7 pages. And I said, whoa, that's interesting. Well, we got the final lottery outcome, and the target that we were all supposed to have viewed was TWA at the bottom of the ocean. She was the only one that got it right. We were all wrong. And that sort of said, what happened? Like, I was looking at the data, and when I turned the page and I said she can't do that anymore, she didn't. It was like she was following my thoughts. And that sort of said, and believe me, I'm not exaggerating when I tell you how many nights we stayed up till 3 in the morning doing session after session after session, telling the spouses, please be patient, while we tried to sort this thing out. Finally, we figured out, and I know this is right. You don't have to believe me. I'll be willing to wait 100 years. It doesn't matter, but I know this is right. There is a telepathic connection between the person who does the viewing and the person who analyzes the session for the first time, because the person who analyzes it is the cause of the session being done in the first place. Meaning, the session is being done to satisfy the informational needs of that person, of the person who's doing the evaluation. That person is the most important person. And that person's thoughts, when they are analyzing it for the first time, determine the target. The lottery does not determine the target. If you had the target picked by a computer at random, the lottery, the computer, the stock market, none of those matter squat. They do not determine the target. What determines the perceptual focus of the remote viewer is the intellectual telepathic connection between the analysis and the doing. I do it for the intent of solving that person's problems, and when that person analyzes things, that's what causes it. So then I said, well, look, there's an assumptive focus for the analyst, meaning I'm assuming this is the correct target out of 2 possible targets, target A or target B. And there's a perceptual focus of the viewer, tugging around between target A and target B. And depending on dynamic initial conditions and the structure of the cusp, this is a catastrophe theory model, the viewer gets pulled into one or the other, or sometimes gets stuck in limbo land and sort of brings in stuff of both. Now listen. Why can this be? Well, this can actually happen. This can actually happen in a universe that is different from our own in the way we think about it. Not different in reality, but different from the way we think about it. You see, Newtonian physics told us that everything is physical, time is real, things are solid. And Einsteinian revolution changed that by saying we have to understand there's some variations at the margins, especially when you deal with Einstein's general theory of relativity, dealing with gravity, and the special theory of relativity, dealing with velocities. But it's on the margins. But you see, there's another revolution, quantum mechanics, And that's really caused a big problem. Roger Penrose said at a conference that I spoke at this year, but he spoke at before, in Lucerne, that physics has got a real schizophrenic personality right now. Everything is built up of quantum events, and they all have quantum reasons for those quantum events. But then when you get to the macro reality, all that quantum stuff goes away, and you have macro reasons. And the two theories just don't mix. And I was talking on a stage in a plenary session with Hans-Peter Joer, the former head of the Max Planck Institute, and I was arguing for why we need a generalization for quantum mechanics, because some of these results that I was at a conference together with Dean Radin, so I said, some of the results that we are talking about simply don't match what you're getting in the macro world. They match what you're getting in the quantum world. And so there must be a generalization. And we got into a lot of technical arguments over the session and during dinner about what that should be. But basically, take a summary view of what it implies. Imagine a situation in which we have a Planck's constant. Imagine a situation in which there's a Planck's dimension. And this is one way you can get at the other universe theory. It doesn't happen to be the correct way. It's just one way it's possible. And some people are talking about it. And we have a value of Planck's constant there in joule seconds. And you have one dimension for this universe. Well, anything that's in this universe can only go up and down that line. Can't see anything off. Well, let's say you have a two-dimensional physical universe. One dimension here, and one dimension here. And Planck's constant is a value on a Planck's dimension here. Well, anything on this physical two-dimensional universe can only be on this plane. Anything off of this plane, they couldn't see. Well, what if you had two of those with, instead of one Planck's constant, you had another value that was permitted? No one knows why Planck's constant is Planck's constant, but let's just say there was another value. Well, you'd get two different universes, and they could not see each other. They could only see, people that were on those universes could only see that which is on that universe. Well, let me tell you about a fascinating experience. If you're in a physics class, every first-year physics student in their first course in quantum mechanics does this experiment. It's called the two-slit experiment. What you have is a monochromatic source of light. It's usually a laser, but it can be from a normal source going through a prism. But they want monochromatic so that they get one frequency. And then it goes through an aperture that can be reduced in size. You can dim the light and reduce the aperture so much that only one photon at a time gets through that gets through that aperture. So you have light coming through. Now, if you have a lot of light coming through and it hits this barrier that has two holes in it, let's call it two slits. Well, those two holes will let in light, and the light will come through here and through there, and like two waves that pass by a pier, and the pier splits the waves, and the waves at the ocean then mix after the pier, they interfere with each other. So the peak of one wave, when it meets the peak of another wave, they'll amplify each other. But when a peak meets a trough, they cancel each other out. When they meet two peaks together, you have constructive interference. And when a peak meets a trough, you have destructive interference. And they flatten each other out. Well, where they flatten each other out is a very important thing, because right after here, we'll call this a photographic plate. They're actually more sensitive than that, but nonetheless, in the old days, that's what they used. So you have a photographic plate here, and what you get is bands. So what you get is light where there's light, and then there's dark, and then light and dark. And the dark is where the waves that were having a peak hit the waves that were hitting a trough, and they canceled each other's out. And where there's light, you actually get two peaks meeting or two troughs meeting. So you get a banded pattern. Now, the interesting thing is when you reduce the amount of light that gets into the system by reducing the brightness of the monochromatic source and reducing the aperture so that only one photon at a time gets in, you will get the photon going through here, and you will get a dot along this plate, a single dot. That means one photon got in, and that's it, and it leaves a dot. You're happy about that. Well, then you let it go on. And you let it go on and on and on and on, one photon at a time. And you know what you'll get? You'll get this. And you say, wait a second, how can I get a banded pattern? Banded patterns happen only if there's interference. One photon at a time. What was it interfering with? There's nobody. It was alone. It didn't have a date. So the point is, you still get a banded pattern. It's still interfering with what is it interfering? So the question is a big question, and there is no resolution to date in the quantum mechanical world. They actually have theories about it. Some of them are very interesting theories, but there is no firm resolution as to what actually happens. But what we do know, and this is a real twister, is that these photons only appear when you look at them, when you register them in some way. No quantum mechanical event actually happens unless it's registered in some way, to paraphrase John Wheeler. So what you're actually seeing is something that only happens if you look at it. And if you don't look at it, the photon exists, but it exists only as a wave. It doesn't exist as a particle. Now listen, this doesn't have to happen just with a little thing on your desk in a laboratory. Consider this conceptual experiment that's been talked about in physics and has been troubling physicists for a long time. You have a quasar. It's very far away. Very far away. And it's so far that light is coming out and we don't get much light of it. But one little photon comes along here and it runs into a gravity well that splits, because of Einstein, it splits the photon into, because it's a wave, hasn't been seen yet, it splits it into two, and so you have a photon on one side of the galaxy and a photon on the other side of the galaxy, and you eventually observe it over here. And you observe it, and you know what you get? An interference pattern. Now, it's one thing to say, it's a little confusing because the photon went through two slits at the same time. There was only one of them. But it's really worrisome when a photon is on two sides of the galaxy at the same time. That's very disturbing. Well, let's actually construct a world. I'm going to introduce a terminology to you, and the reason I'm going through this is I'm trying to explain to you why remote viewing actually works. This is a bunch of sine functions, all here. They're just a bunch of sine functions. Bunch of sine functions, that's all they are, folks. Bunch of sine functions. Sine functions go up and down and up and down. Let's add them together. I'm tired of looking at all of them like that. Let's just add them together. Whoops, what'd that happen? All I did is add them together. That, folks, is called a superposition. It's a really cool thing. And when you get waves that interact among themselves, they form a new thing. You know what that is? Well, it's a collection of sine functions, but in physics terms, that's a photon. That's a particle. See, a photon actually has a distribution. It's not a thing that you observe until it's not a thing that's actually existing until it's observed. Before then, it's a distribution, and it sort of exists a little bit over this way, and it also exists over this way, and somewhere in the middle. Not too much over there. It's sort of over there, too. But then we measure it, and it's right here. One of the questions is, how come it only appears when you measure it? Well, one of the answers that are offered is it's actually all over the place. You're just picking one place where it may be out. But reality, what it is a superposition. There's an interaction. It's only a wave. It's an interaction between the photographic sheet, the observation, and itself, creating a superposition that you then see through constructive and destructive interference. Then you can say, well, wait a second here. I mean, I learned ever since I was in middle school that there are particles and atoms and molecules. And I said, yeah, you did learn that, but that was never the right stuff. No physicist has ever found a particle. There is no such thing as a particle. They've never found one. They've never seen one. They have never found one. But there's a neutron. No, there's no neutron. If you bash a neutron, you eventually break it up into its constituent parts. And eventually, you get things that have no mass, point sources like quarks. You don't actually have a billiard ball type of a thing that's rumbling around. But wait a second, I know there's mass. Look at my hand. It won't go through here. It's not because there's physical atoms bumping into each other, bouncing. Waves resist displacement. Waves, forces, fields resist displacement. My hand won't go through here. Any physicist will tell you my hand is almost entirely empty space. This podium is almost entirely empty space. If there were particles, trust me, my hand would go right through this thing. There's only empty space here. Fields resist displacement. There are some physicists who are called particleists who are still trying to look for particles, but honestly, most have given up the ghost of finding a particle. What they find is things they call particles, and that they shoot them at cancer patients to try to get rid of cancer, and they do things like that. But no one's actually found a particle. I mean, a real solid billiard ball type of a thing. What you do get is waves. What does that mean? you're looking at me. I'm not a solid thing. None of you are solid things. There is nothing that exists in the physical universe but waves. That's the conclusion of remote viewing. Remote viewing works because waveforms can act in synchrony and create superpositions. Waveforms with other things. And waves are fundamentally composed of component waves. And those waves extend through all of space. Any physicist in your first introductory course will tell you that. So you can remote view because the waves upon which everything in your mind is based, all processes, including physical things, processes if you go in the direction of David Bohm and Hiley's interpretation of quantum mechanics, which has been popularized by Michael Talbot. Very interesting read, but Bohm's, if you have the mathematical background, Bohm's original stuff is, Bohm and Hiley's, their original stuff is extremely interesting. It's nothing but well, they like to call it a hologram. There is nothing but waveforms that interact, that produce us. Well, superpositions is what we are. Can waves exist outside of a medium? I was talking about this with Hans-Peter Dohr, former head of the Max Planck Institute. He was telling me, well, look, there are no hidden variables. We've thrown that out. And I said, yeah, but listen, you do have entanglement, and something's happening over there, and it's affecting something over here. Why can't you have something in the middle? And he said, well, what would that be? And I said, well, look at it this way. There are lots of phenomena about which we know there are waves, and we can't measure them or do anything about them. For example, cosmic rays. The energy of cosmic rays is so high, 10 to the 27th power, we just assume, because the wave-particle duality exists all the way up to high energy levels, we just assume that those waves exist. The only thing we can measure is the energy level. But we can't do anything with those cosmic rays. We don't see the waves. We see particles, evidence of particles, but we don't actually do or see anything with the waves. We just assume it exists. So I said, why can't you assume higher frequency waves? Frequencies that would fill the entire universe, upon which all of material existence would exist as superpositions. And he said, well, what would they be like? And I said, they had to be very high frequency, and you're dealing then with something you might as well call Planck waves. Why Planck waves? And I said, because, and then he finished his sentence, because they'd have to be at the Planck scale. You're right. Yeah, they'd have to be at the Planck scale. Very high frequency waves. We just simply can't see them. We don't have any measurement. It's like trying to pick up a needle with a bear claw. We don't have any measurement ways of currently getting at them. But I'm convinced they must be there. And there are some physicists, notable physicists, who all also agree that some things like this must occur. Let's create a little universe. Here is I work at differential equations, so this is a differential equation system. I've got 4 of these little buggers here running around on a time axis. Looks like sine waves, but they're not. They're from these are paired harmonic oscillators. Let's have a bunch of them together, and let's actually suppress a few dimensions. So instead of 4-dimensional torus, you're going to get a 3-dimensional toilet paper tube. All right? Okay, so what you get with something like this is very interesting, because you get a universe right here that's made up of waves. I'm a modeler, so I like to construct simple models to sort of figure out what's going on in a more complex world. This is not a model of the universe. This is a toy. But it's my way of playing with what I think conceptually is going on with the universe. And what is this circle here? Well, this is a plane that I'm intersecting this toilet paper tube universe with. And actually, this is called a Poincare map. But we don't need to worry about the name. It's a plane that actually slices this tube. And it intersects those places in the universe on those dots. Well, let's call that Poincare map, or the plane that's dissecting the toilet paper tube, let's call that an observation wave. Everything's got to be waves, right? There is nothing but waves. So let's call that an observation wave. And what it's doing is creating superpositions right here in that circular area. And if you're in the universe of this thing right here, at the observation wave, that's all you're going to see. You won't see stuff that's in the universe that's created by waves outside of it. Now, if you look at that universe from the top, that's what you'll see. And if you don't mind being a little Star Trekian, flying into it, that's what you'll see. You fly right into the toilet paper tube. Okay? So basically what you have is you have a probability sequence axis that's dominated by waves, And you're going to have events flowing along that probability sequence axis, and they're going to manifest at places where there is greatest probability, according to the underlying tapestry of Planck waves. Now, this is a theory, but it is a theory that matches the facts on the ground with regard to the remote viewing phenomenon. Let's think of some important considerations. Perceiving the future. Can you do it? Yeah. We do targets all the time, but the targets are chosen 2 weeks ahead of time. Replicable public demonstrations. We've been there, we've done that. We'd like to do it again. We're actually looking for a luminary. I'm actually talking to some of the other people in the other remote viewing groups to see if we can get people in different groups to do a public demonstration at the same time, 2 viewers at a time. We were looking for a nice luminary that people would trust to pick the targets. Yeah, we're violating relativistic limitations, that's for sure. Everything's being violated here. Changing the future? Yeah. Military people do this all the time. You try to remote view a terrorist event so you can prevent it. Well, what did you remote view? If you have a wave-oriented future, if everything is waves, well, that future is still existing. If you saw something that bad happened and you prevent it, you did remote view it, and it's still existing somewhere else. It's just not your trajectory into the future. Fascinating stuff. This is the type of thing we consider. Some important implications. Physical reality is all superpositions. What we see are in-phase superpositions. Out-of-phase realities, theoretically, they should exist. And the remote viewing is a really great way to start exploring those realms. Dick, give me a minute. Don't cut me off. Okay. Alternate timelines are thus not science fiction. It's a real possibility. You see, as long as you avoid the trap of saying everything's solid matter, you see, you can't have other realities. We'd bump into each other. Where would the other you be? You'd smash into it. But if everything's in the form of a wave, it could coexist in the same space. Nothing would bump into each other. Well, let's talk about associative remote viewing. So many people are interested in that. Remember the old story I told you about when I was judging the sessions? And my thoughts affected? We learned a couple things. Not just from that, but from tons of tests we did afterwards. The thoughts of the analyst matter. Everybody's thoughts matter. You see, I had prejudice against a woman who was a remote viewer. She was great. I was the one who was wrong. She did a great session. My prejudice, that was part of my thoughts. That determined her target. She was supposed to follow me in the beginning, and then she was supposed to go off in another direction afterwards. That was what I was wanting her to do. Those are my thoughts. And she did it. Thoughts matter. Now, IRVA is a mental process. Everyone's thoughts matter. Now, I'm going to talk about Sam in a second, but I'd like to go to Professor Utz's presentation, which you heard earlier in the morning, because she had a very interesting discussion, and it brings up a particular experiment that people who are involved in psi experiments would argue about. And so I want to show you where an argument would be. I'm not saying I'm right. I think I am right, but other people would say I'm wrong. So what? It's fun. It's a really great thing to be in science. Remember the experiment that she was talking about? Really interesting experiment where there was a sender and a receiver. And the sender was supposed to be sending information back to the receiver where what the target was, what that sender was. And then in the future, John, the analyst, was supposed to be judging. And John had a list of, I think it was 5 targets, 4 decoys, and 1 reel in front of him. And he had the remote viewing data and was trying to figure out which one of those targets was the correct one, looking at the data, the remote viewing data, and comparing the targets. Well, now listen, folks. This is the biggest mistake made completely, bigger than all the others that Professor Utz was talking about, from one side of view. It doesn't mean that she would agree with me, or it doesn't mean that other people who do psi experiments would agree with me. Just from my point of view. The biggest mistake is that John was looking at a set of targets, a collection of targets. You see, the remote viewer was receiving that information telepathically from the sender. So you're already assuming telepathy works for the purpose of satisfying the informational needs of John. John was the big show in town. It was him that really mattered. And why should you believe that the telepathic connection between the sender and the receiver stops there? It's like Truman, the buck stops here. with remote viewing, the buck doesn't stop there. John was more important than anything. And John had 5 targets in front of him. So what are you going to get? You're going to get a displaced target. And the better the remote viewer, the more times you will get a displaced target. The less noise you'll get. You'll get a target that's displaced. You'll get the right target, but it's not the one chosen by the dynamic event. The dynamic event doesn't matter squat. Now, the response is, but we have lots of statistical evidence that shows that this experiment does work to demonstrate the existence of psi phenomena. There were other things going on. Afterwards, people look at the data again and say, well, look, this was the correct target. So there's more of a focus on the correct target. So statistically, in terms of people's thoughts, there's more effort being placed on the correct target than the others. But you should get a weak association. And that's exactly what you get, a weak association. Why is it that the military can do remote viewing and get profound target penetration, and the psi community gets a weak association? Because they're using target lists, and they're getting a complete contamination, not a non-optimal result, but a complete contamination because of cross-cutting psi channels, displaced target, of the data that they're collecting. That's what's going on. And I will take my reputation and say, wait 100 years, drag me in the mud, do whatever you want, but that's correct. What do we do now? To get around these problems, we have to redesign these psi experiments. So what do we do now is we say, first of all, we can have prejudice when we judge. So first of all, the judge should be not a person. It's better to have a machine do the judging. Now, I was not the first person to write up a computer program to analyze remote viewing data, but we have a good program, and it's free, and it's available at our website, farsight.org, and it's called SAM, Session Analysis Machine, and it comes with an instruction manual, and I encourage you, please, to start using it. Actually, there's a much bigger version, and as soon as people start using this one, 1.0, I'll put up version 2.0, 3.0, 4.0, has all types of fancy things going on. But it's a way to analyze and completely work with sessions without having a human analyst, getting those thought processes out of the way. So that's very important. There is also the issue of partial perception, meaning sometimes SAM doesn't always work. Sometimes the sessions really aren't so great, but I'm sure you will find that it works better than a human judge. I know I'm running out of time. How much?
You're good.
I'm good? All right, all right. Let's talk about types of targets that we think should be used. Again, I hope this generates debate. I know other people and other groups like to use different types of targets. Sure, I have opinions about what I think is right, but these are strong-minded people that we're dealing with, people in other groups, the leaders of other groups, and they're really smart and really good. I love these types of debates. These are good. But this is our view, at Farsight, what constitutes good targets for public demonstrations as well as for associative remote viewing experiments. Well, they should have very prominent topological features. This is very important. You should be able to know that the person remote viewed something because it really looks odd, and the pictures came back and they're really odd. The sessions that Dick Algar was showing you, it was very clear. There was no ambiguity. Very clear topological heterogeneity. And when you do many targets, they should all have different topologies. So you can say, well, you have a bunch of targets you've done, and they are different. When you do the Eiffel Tower, it really looks different from when you do somebody going into Antarctica. And that really looks different from a battle over the ocean. Which raises the issue of how do you analyze psi experiments? How do you analyze psi data? You see, this gets back to the beginning of the presentation. How did because of psi war number 1, how did psi scientists try to compensate for the moving of the alpha level? Well, they did it by increasing the sample size. And they wanted something that would work with statistics. That means that they said, I need a larger sample size, and I really want something that'll be easy to understand, hit or no hit. Hit or no hit. So what they would do is basically take people, try to train them in some way, and get them to try to make perceptions. And then to boil that down into a hit or no hit, and then to amass that, and find out if you have a statistically significant result with those hits or no hits. And then, when the alpha level gets moved again, they say, okay, I need yet a greater sample size. So then you get into things like meta-analysis, where you do studies of studies. And tremendous work very valuable work has been done by Dr. Utz on things like meta-analysis, where you study studies of studies, amassing very large statistical significance, very, very profound statistical significance. But the problem goes back to the big bully on the beach and wanting to increase the sample size. What if you didn't listen to the big bully? Listen to this. Dick Agar was up here, and he showed you sessions, and he told you how long they are. CRV, SRV, HRVG, Mount Baldy sessions, good, solid people doing good, solid methodologies, their own. Those pages are like 20, 30 pages of results. That's 20, 30 pages of data. You're going to take that incredible heterogeneity of data and crump it down into a hit or a no-hit? That's ridiculous. You have 20, 30 pages of data, code those data, and then get another data set that's coded for the target so that any scientist can look at the target and look at the coding to see if they agree. Both the session coding, make it all open. Make a wiki on it if you want. Make it so that anybody can make their own judging. And then a target data set, and then compare the two. And then you can develop tremendous statistical tests, a zillion of which are already built into SAM, to tell you whether you got the target. And then if you want to know if your target was different, maybe you just happened to always get Mount Everest targets and that was a good Mount Everest target, well then do 10 targets. And then you can compare your results for that target with, and Sam will do this for you, with 200 or 300 other targets that are collected. Meaning you can statistically compare your target results with your 20 pages, 30 pages of data with targets, 1,000 of them. Sam will do 1,000 of them, 10,000 of them if you want, to see how unique it is. And what you should get is a very high correlation between your target and your session, and much lower correlations with targets that are much different from the correct target. Point number one target per session. Whatever you do to test for psi, you must not have multiple targets. You must not have 4 decoys and 1 reel, and the 1 reel being chosen by a random dynamic event. That dynamic event doesn't matter. It's the thoughts that matter. So the other thing we did was, when we end our session, we close it. We close the loop. So we let the viewer be the first person to compare her or his data with the target. So when the tasker sends in, or the targeteer sends in the target 2 weeks after the sessions are done, the first person to get it is the viewer. We post it up on the web, but the first person that gets it before we post it is the viewer, and then the viewer can look, closing the loop. If there's a prejudice, the viewer is going to do it herself or himself. It's not going to be somebody like me, some jerk like myself, saying, she can't be as good as me. Let her close her own session. Get rid of my contamination. And then post the session. Well, the session's already been posted. Post the password to de-encrypt the session, and post the target. Let it all come out, and begin demonstration number 6 or 7 or 8. By the way, in the demonstration we did, it's all up on the web at farsight.org. You can look at them. Basically, out of 13 completed sessions, 11 of them came out really great statistically. Really, really great. So, one target, isolation, target isolation. Glenn has talked to us about this with me lots. He was one of the first persons to talk to me about this, Glenn Wheaton. Target isolation. Keep that target away from anything else. Dick has talked to me about that. Target isolation. Target isolation is really important. Thoughts matter. Everybody's thoughts matter. Okay, by the way, what did I do here? Okay. Oh, yeah. Macro targets only. Real quick. I'm going to zip through some of this, but the next slide is going to be important for you. Macro targets only. Big targets for public demonstrations and for associative remote viewing. That's the way we feel about it. Do something you're different if you want to, but that's how we feel about it. No micro or embedded targets. A micro target is a small target that's surrounded by a large environment that's interesting. The large environment always attracts the interest of the remote viewer. I saw a session once that was judged by someone who was doing a psi test where the target was a flower pot in somebody's house. And the session was scored at a miss. The session was great. They had the house, unique architecture, everything was there, but they missed the damn flower pot. And it was scored a miss. I looked at that and I said, holy Moses, this is ridiculous. No micro targets. If the target is the house, that's okay, but forget the flower pot. They may get the flower pot, they may not get the flower pot, but the house is the big one. Activity is good, but not always. You don't want to have everybody expecting there's always going to be activity, but try to mix up the thing. Have lots of activity. Some, people climbing Mount Everest, going across Antarctica, battle wars going on in the middle of the Atlantic, but don't have everything. Have a static picture of the Eiffel Tower sometimes, and so there's mixes. But no micro and embedded targets, as I've already talked about. No empty or flat targets. That means do not give Tiger Woods golfing on a golf course. You may have a perfect picture of Tiger Woods, but no one's going to believe that was remote viewing. It's just a single person on flat land. So what? There's no unique topology in that. Avoid personal stories that are really interesting. Tiger Woods may have a great biography, but that's not a great remote viewing session. If Tiger Woods happens to be up on the top of Mount Everest, do him. But if he's on a flat golf course, just forget it. Go to a different target. No flat or flying targets. Absolutely no esoteric targets. And this has to be really demanded. In our public demonstration, we had a targeteer. The tasker give us a target that was a crop circle. It ruined the whole experiment. We had to throw everything out. No esoteric targets. Besides, it was flat land, a drawing on flat land. If we did the sessions, in fact, we came up with a castle. Turned out there was a castle nearby. It was the only thing interesting. The target was the crop circle, but we couldn't find anything there. It was just flat land. Oh, look over in that area. There was a castle. So we described the castle. No esoteric targets, no flat targets. Now, it doesn't mean that those aren't good sessions for other purposes. I'm just saying for public demonstrations, make it something that people can believe, something that's got a really unique topology, so people can say, you drew it, and it's there. Hey, that's weird. All of the stuff must be publicly available as well. Verification must be immediate. That's what helps make it science. No esoteric targets. Now, let me drill in this point. These are really good targets. Really interesting topology, structure, person. Really interesting structures, large groups. Very interesting topology here. Lots of energy formations, very interesting topology. Same here, same here. Very good topology, very nice topology. Those are good targets. Let me just cheat on this slide a little bit and say, let us say you were judging a remote viewing session and you had the data in front of you and some computer picked one of these targets and you're trying to look at the session and look at these targets. And that person did that session to satisfy your informational needs and you're looking at all the data spread out right in front of you and you're looking at all those things. What's the target? Damn the computer. Everything on that page is a target. And you can go to anything. That's the displaced target phenomenon. You know something? When I say things matter, everybody's thoughts matter, it reminds me of the Federal Aviation Administration. A while back, a jet crashed. And they said, speaker for it said, very unusual thing. It won't worry. Everyone keep flying. No problem at all. It was such an unusual fluke. 2 engines went out. The probability of 2 jet engines going out is like 1 billion to 1. The probability of one of those jet engines going out was really small, and he gave it. And the probability of 2 is like ridiculous. I looked at that report and I said, who was he trying to kid? What did he do? He took the probability of 1 jet engine going out, multiplied it times itself to get at the joint probability of 2 engines, as if they're independent events. They're on the same plane. How can they be independent events? They had the same mechanics. They were stored in the same place. They got the parts from the same place. How can they be independent events? Things are not independent. When you're judging something, don't assume, hey, what happened at the session was over there. I'm free. I can do anything I want now. It's not independent. What you think, if you're the judge, makes the difference. You're the most important person in the entire process. You're the reason the sessions were being done for. If there can be a telepathic link between a sender and a receiver, you can be darn shooting there can be a telepathic link between the viewer and the closer. That's why we like to have the viewers close their own session. They make a telepathic link with themselves. It sort of keeps it a little cleaner. These are bad targets. Crop circles, esoteric content, maybe. A lot of crop circles. You should talk to Simeon Hines. Some of the crop circles are, a lot of crop circles are of human invention. Some of them apparently are not, but some of them are, a lot of them are. Really clever people, but also anomalous events seem to happen around that. Simeon's been talking to me about that for the longest time. He's the expert on the mixing of remote viewing and crop circles. Fascinating person to discuss things with, but that's a lousy remote viewing target for a public demonstration or an ARV experiment. Flat land, a line, designs on flat land. That's no good. That may have a tremendous story, that young boy in Uganda suffering from the Ebola virus, but that's not a good target. You're not going to get all the emotional stuff out that you need on a reliable basis and code it into SAM. SAM doesn't even have the emotional stuff like that that's suitable for it. You may get the building and people and the sense of not things being too good, but you want clear associations. You really want topological variety. This is too complicated. This is good for a monitored session or a training session in any field, HRVG, SRV, CRV, whatever, Mount Bolding processes, but it's not good for a public demonstration or an ARV experiment in our point of view. Richard Nixon, that was once given to us by a tasker. That's the worst target. Richard Nixon when? When he was being born? When he was giving a speech in heaven? What? You can't just say Richard Nixon. So you have to train your targeteers or your taskers. It's a no-joke thing. They have to know how to do it. And you've got to be rigorous and test them. And if they do it wrong, the whole thing goes out. You say, you screwed up. This one's all lost. We got to start over again. Okay? Tiger Woods on a golf course. I already talked about that. Flower pot in somebody's house. I already talked about that. Don't give somebody a bug for a target if you're doing a remote viewing session. My gosh, you're likely to get the mountain that the bug is on, but miss the bug. I mean, the target's supposed to be anything, right? No micro targets, no embedded targets. Targets that are embedded have an interesting surrounding around them. That's what's going to attract the remote viewer. Give them the surrounding around them. All you want to do is to know if the target's A or B. And then, of course, no jungle bar set in someone's backyard. These are examples I've actually seen. You'll get the backyard, you'll get the whole house, but you may not get the jungle bar set. Okay, last thing I want to say, and then I'll open up for questions. How did I do on time?
Hey, you haven't been here in a long time.
Okay, okay.
You've never been here.
Okay.
Take your time.
The last thing I want to say with regard to this is
You have a lot to say.
I have a lot of opinions. I speak forcefully about them. I'm not saying I'm right. I think I'm right. But nobody should be up here if they don't think they're right. This is the controversy. Dr. Utz was up here before. She wasn't saying, you know, don't argue. What was the title of her talk? You get benefits by arguing. We don't need orthodoxy in this science. I actually saw an article in the Society for Scientific Exploration where they talked about a remote viewing test where they were looking at the 5 targets, one being real, the other's decoy, and they called it the standard procedure that's now accepted. I looked at that and I said, what? There's no orthodoxy. There cannot be. We don't understand it. They didn't even understand what caused the remote viewer to focus on one thing rather than the next. How can there be a standard procedure? You need to experiment. Thus, you're going to get argumentation. One of the biggest gripes I have about the way science is presented in America is that we do not present the excitement of it. We don't present the excitement of mathematics. I'm a mathematician. Jessica Utz will tell you that they don't present the excitement of statistics. Most people say, I hate taking statistics. Do you think Dr. Utz would have become a professor of statistics if she didn't love it, if she didn't breathe it, if it wasn't in her veins, if she didn't feel viscerally that it's exciting? Do you think I'd be a mathematician if I didn't think it was exciting? It's tremendously exciting. Why is everybody out there focused on Britney Spears? And I don't mean to gang up on Britney Spears, but listen. The problem with America is this. The reason why everybody isn't focused on remote viewing right now is there's an anti-intellectualism in the American culture. When Bill Gates goes to India, standing room only in arenas as far as the eye can see, scalpers, $150 tickets, people are climbing into the windows. Bill Gates is India's Britney Spears. The problem with America is Britney Spears is our Britney Spears. He's got to go to India or to China to get people to really understand this is cool and sexy. Whenever you see a scientist in the movies, what does everyone think of? Back to the Future, right? A weird guy, frizzy hair. All scientists don't have frizzy hair. But when is the last time you actually saw science portrayed as cool and sexy? That would make people want to go into it. I have to really try to convince my students at Emory that science is really cool. The reason why there are a couple hundred people in this conference rather than 10,000 people at this conference, you get like 5,000 people at Mathematical Association of America and the American Mathematical Society joint meetings. You get 5,000 to 10,000 people at those meetings. Why aren't there 5,000 to 10,000 people here?
Their jobs depend on it.
Well, no, it's not such a job. Those people love it. Those people love it. The reality, what's that?
If they didn't get paid for it, they wouldn't come.
What?
If they didn't get paid for it, they wouldn't go to the conference.
No. I'll open it up for questions right now. The reality is, you should see them. They're at the edge of their seats. The point is, what you are doing now, what's different between you and the rest of the country, is that you are interested in this aspect of science. What I want to leave you with is the following notion. You are very, very special. You are the only people that came. Paul Smith is very special. He's the only one that organized this group to meet. Dick Algier, Glenn Wheaton, Simeon Hine. These people, Lynn Buchanan, are very special people. You are equally special people. Out of 300 million people, you came. And this is going to be the area of science that's going to rivet some significant part of this century. We, as scientists, are depending on you to understand the science as best you can and to talk about it so that other people get interested in it. In terms of my component, remember, this is a brief view of some of the stuff I've talked about in the book, Remote Viewing, Science and Theory of Non-Physical Perception. I do hope you get it, and I do hope you read it. God bless you.
And one of the reasons we're so focused on Britney Spears is that damn media. Those people in the media. Let's have a question. You have to come forward from the...
Okay. To rule out the analyst's perceptual focus on RV targets, have you tried using third world people without any visual exposure, children, or people that were born blind?
You mean as targets?
As perceivers, as people that are intakers, that are giving
Remote
you the
viewers.
information.
Oh, that's interesting. I think you're asking, have we trained people who were like physically blind?
Or have had no visual exposure at all.
Or had no visual exposure? Some people with disabilities.
Third world country that don't have TV, radio, or children that have not had the exposure.
Actually, I traveled to the third world. My wife is from Africa, Kenyan. And I like going there, but I speak about politics and mathematics. When I go there, I don't speak about this. No, we've not done any training out there. And one time I did think about the idea of training people who were physically blind to see if that would work. And my wife, who's a chemistry teacher in high school, yanked my neck about as hard as you can yank it and say, don't you dare do that. People were saying, they're going to start, the masses out there will start saying, you're trying to play Jesus by trying to teach, make the blind see, just stay away from that. The science is too immature, so you got to stay away from some subjects. So that's a subject I haven't done. And there are other people who apparently have tried that, but I'm skittish.
My career is in ophthalmology, and the blind that are born with blind do have perceptions, although it's not as the same as us, but it's touch and smell.
It's a very legitimate question, but I'm scared to even touch anything dealing with medical.
But
The Medical Association is very, very, very big, and there are some gorillas I don't want to wrestle with. So I don't touch anything dealing with medical stuff.
But Courtney, wouldn't you love to have viewers that you could lock up in a dark room that don't watch TV or read a newspaper?
Yeah, it would be cool.
Yeah. That's what Glenn wants. Okay, you got to come forward.
Okay. Courtney, thank you. This was great, and your points of view were well presented. Now, with respect to, and you said it, the D word, displacement.
Yeah.
Okay? First of all, what I want to say is I don't think there's any question, in my opinion, that the judge, the analyst, is connected with the viewer. Absolutely. So we totally agree. one of the things I didn't understand was why you said when what we all have in ARV is the feedback session. Why couldn't the feedback session, connecting up with the viewer, be more important than what happens when the analyst looks at these multiple targets?
That's probably why you have mildly statistically significant results, because it probably adds some emphasis to one target rather than the other. But you're still going to get that displaced target phenomenon. We have tried this and tried this and tried this. We've not found any way to get around it. And from a quantum mechanical point of view, if it's not a classical process, but it's fundamentally a quantum mechanical process, and I didn't get into that, that's what I talk about in some other. When I talk to groups of physicists, I talk just quantum mechanics. When I talk about it on that level, if it's a quantum mechanical process, then it must follow the rules of other quantum mechanical processes, and you must get something comparable to the two-slit experiment. They cannot force a photon to end up in one spot or the next. All they have is a probability distribution. They cannot get the photon to appear only one way. They can't do it. They've been trying for 100 years. It's been a long experiment.
Well, that's the ultimate randomness. That's the ultimate randomness.
But that is expected if you understand everything is a wave phenomenon. But that doesn't mean ARV can't work. It just means you have to design the experiments, from my point of view, a different way. By the way, in the manual that is for SAM, I do at the end of the manual go through a simple way to set up an ARV experiment using SAM. We haven't tried that one. It's still something to be done, but it's likely, it seems reasonable that it would work. There's stuff that we're still doing. So I've diagnosed the problem more than I've solved the problem, but I do sense that SAM is the only way to go, or some other computer program is the only way to go. And I understand that there are other pioneers in the remote viewing realm, like Edwin May, that are also doing some stuff similar to their own, using their own programs in a similar fashion. And I look forward to seeing what they come up with.
Well, and exactly, and that's my point actually to you and to all the rest of you. We need to see the data.
Yeah.
The system needs to be set up here where someone embraces SAM, goes out,
or
and
some other
does
program.
it, or Ed May's approach, or something else, and indeed does this for a year or two, and shows a chart where their success rate is up to 80%, 90%. I think that's the kind of numbers that you're implying are going to happen with moderate viewers. 80% or 90%, you're going to do very well financially.
We got to move along. I've got a few announcements I've got to make it, so we'll go one or two more. Dr. Targ, you want to keep it real brief here, and I've got.
Okay, I'm here to represent the frizzy-haired scientists. I agree pretty much with everything you've said, and a couple of points I could add in support of that. The initial experiments we did at SRI, 2 lengthy series of so-called outbound experiments, where we would have a viewer describe where somebody is hiding. The very next thing that would occur is we would take the viewer to that place for immediate feedback, and we would complete all the feedback experiments like that before any judging was done. So there was no target pool as such. There were, of course, a list of 60 possible places, but within the little universe of discourse for the viewer, he described where Joe is hiding. We and Joe would then take him to that place so he would get to experience the thing for immediate feedback. Those experimental series were extremely significant, like effect size approaching unity and odds of 1 in a million for just 9 or 10 trials. So those, and all the work we did at SRI was immediate feedback to the viewer and were shockingly significant. So that's one thing that I could mention. The other thing that I want to say a word about further is that Ed May indeed is doing experiments like you propose. He just described this at the Parapsychological Conference. He did 50 trials with a 1 in 3 game for the stock market, high, low, and middle. And no target was chosen until the viewer had described the proposed target that would be generated the next day. And I won't go into it all, but the description of the viewer was fed into a machine. The machine would then choose 3 targets randomly. Nobody would see the target. The machine would then judge the match into those 3 targets, and a decision would be arranged. Nobody's seen the targets. Eventually, the market would trade. A correct target would be resulted. The viewer and the experimenter would then see those. His results are extremely significant. Yeah. If he counts only the significant matches, out of 12 significant matches, 10 of them were correct and 2 were erroneous, which is what you'd expect by chance. He essentially saw no displacement by hiding incorrect targets from everybody.
Russell, don't go away. Let me comment on what you've just said so far. That's what I'm expecting. That's what I'm expecting to happen. The issue is that something has to pick a target. As long as that something that's picking a target doesn't mess with the viewer and the viewer's reception of a target, the closing of the session, it doesn't matter what happens to the session in the middle. So if you do a session and some computer looks at the data, analyzes the data, and goes and picks a stock for you and does everything, you don't know anything, and then it decides what target it is, it's the same as if a computer picks a random target from a pool and simply gives it to you. It doesn't matter that the computer happened to have bought stocks. Just get human beings out of the process, because what you're doing is, in mathematical terms, you're creating attractors. You're creating an attractor towards another thing. And it's very hard to figure out what person's thoughts, or which person or what thought is actually creating that other target. So just get rid of the people entirely. Have the viewer have one session and one target, and let everything else be done by machine. Nobody that has any connection or with the analysis should have any understanding of what that target is. The target should have been picked by a computer. That's okay. Dr. Utz has been talking about that. That's fine. That's a very good thing. Have the target picked by a computer. Have that given to the remote viewer. Other things can be done, but nobody on the analysis side should ever know that target. Anyway, let the machine do everything. Go ahead, Russell.
I would just say that I think you've got the right answer, that the ARV can be made to work if you just hide the decoy targets from everybody.
First of all, even though I'm from Seattle and I am a scientist, I'd rather watch Brittany Hughes and Bill Gates. But actually, I agree 100% with your idea that the analyst definitely influences the viewer. And my experience was from being an ARV analyst and judge. And I found that I also would submit a target, but my target would always mask the best viewer. I mean, whether the viewer was wrong or right. I mean, and also, when I had them do multiple targets to get around this, the first one I looked at, if it was a good viewer, all the others matched that whether it was right or wrong. Or whether I thought they were a good viewer. So I agree on that. But I have seen it defeated. I have a video of a friend that can pick 50 a whole deck of cards, whether they're black or white.
Yeah,
black or red.
Let me talk about that. Let me talk about then the other one, the first thing you point. There are some situations where people have done things that don't fit within what I've described. Dr. Richard Ireland used to do things, there were an awful lot of targets, and he was able to sort them out. I think, I'm just guessing. Am I allowed to guess? Sure. I think there was a genetic anomaly. I think he just was able to do some things, and that...
He's definitely an anomaly.
Yeah, and I think that I think our biology makes it normally very difficult for that to happen. And there's probably a good evolutionary reason for it, why we came here to be humans in the first place. So, you know, it's actually, I once heard it described that we are the masters of limitations, our species, because we can't see very far into the future or other things, and that gives us special challenges, and that gives us, you know, extra mountains to climb, but we have the potential to grow a lot from it. And I think there are probably anomalies, and so Dr. Richard Ireland may be one of those genetic anomalies. Maybe.
Thank you, Courtney.
Good job.